Unit 9 review number 1, I'm going to look at numbers 10 through 13 in this video. Number 10, a yes-no survey has 3 questions. Below is a list of all possible responses. So either someone answered yes on all 3 questions, answered yes, yes, and no, yes, no, and yes, and so on. It says, what is the probability that a randomly chosen survey response has at least 2 no's? So at least means it could be either 2 no's or it could be 3 no's. But anything less we don't want to count. So what we're looking for the list, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 possible responses. 8 possible sets of responses. We're looking at counting all the ones that have either 2 or 3 no's. There's no. Oh, there's 1, there's 2, there's 3, and there's 4 that all have at least 2 no's. So out of our 8, there's 4 that work, which is reduced to 1/2. So our probability for number 10 is 50%. Number 11, triangle ABC. This is going way back to Unit 1, back at the beginning of the year. Triangle ABC is rotated 270 degrees clockwise about the origin. Find the coordinates of vertex C prime. So this point C, that's what we're concentrating on. That's what we want to find. If we're rotating 270 clockwise, you could use tracing paper. I don't have any right now, so what I'm going to do is I'm going to rotate the paper, actually, to find where this point C is going to land. Now, if we're going clockwise, clockwise is this direction, about the origin. My pen goes here. I'm going to start rotating the paper. There's 1/4 turn is 90 degrees. There's 180. And there's 270. So what happens when I do that, when I rotate my paper like that, this becomes the x-axis, this becomes the y-axis. So if I'm trying to find where C is, this is showing me right here where the C value, where the point C prime is going to land at. Now for the coordinates, I'm going from 0, I'm going left 1, 2, 3, and up 1, 2, 3, 4, 5, 6. Left 3 is -3, up 6 is +6. And that right there, by turning the paper, shows me exactly where point C lands. So my answer is -3 and +6. Number 12, in triangle TUV, there's TUV. TU is congruent to TV, so these two sides are equal. And the measure of angle V equals 35 degrees. Find the measure of angle, well, let's call this measure of angle T. So to find angle T, we know because this is now an isosceles triangle, these two sides are equal, we know that these two base angles are equal. That's isosceles triangle theorem. So since this angle V is 35, angle U is also 35. Now we're asking to find angle T, so we're going to take these 35s, we're going to add those 35s, we get 70, and then we're going to take that 70 because the triangle angles in the triangle add up to 180. We're going to subtract 70 from that. So angle T is 110 degrees. Number 13 gives us the parallel lines. This diagram should look familiar. It's been a while, but you've worked a lot with this. It says line P is parallel to line Q. Both lines are cut by transversal T. The expressions are the measures of the angles in degrees. You have 1, 2, 3, 4 angles labeled. Now part A says write 3 different equations that can be used to find the value of x and write a justification for each question. In other words, write a theorem or postulate that is the basis for your equation. I'm only going to write 1 equation. You can you should be able to find 2 others. But there's lots of different relationships here. We have this pair of angles that are vertical, that are across one another. Vertical angles are equal, so you could write these 2 expressions equal to each other. These 2 make a straight line together, which means they add up to 180 because they are supplementary. These 2, same thing, they make a straight line, which means they add up to 180. This one and this one are alternate exterior, which are equal. So there's lots of different ones we could use here. Now what I'm going to do is I'm going to write, I'm going to choose the first pair I said, these 2 that are across one another. 3x minus 4 equals 2x plus 24. justification, vertical angles are equal. Now again, you're on your own to write the other two equations, but if you listen carefully to what I said earlier, you should be able to get those two. Part B, find the value of x using one of your equations. Write a complete solution beginning by repeating the equation and justification from above. I'm just going to write the equation, 3x minus 4 equals 2x plus 24. Vertical angles are equal. Subtract 2x, and I can do this all in one step. Add 4, the x is on the left side, the numbers on constants on the right. 3x minus 2x is x, add 24 and 4, I get 28. Now that's not one of the angles, that's the value for x. Part C, find the measure of one of the obtuse angles. Write a complete solution. We'll go back to the diagram. One of the obtuse angles from the two that we used was 3x plus 16, which is, there's your big obtuse angle. So I'm going to take 3 times x plus 16. I'm going to plug that 28 in there. 3 times 28 is, I think, 84. Yeah, 84 plus 100 plus 16 gives me 100 degrees for the obtuse angle. Part D, find the measure of one of the acute angles. Write a complete solution. Well, if 100 is one of the obtuse angles, 180 minus the 100 gives me 80 degrees. And in that diagram, anytime you pair up one of the obtuse angles with one of the acute angles, they will be supplementary because they will make that straight line. So 180 minus 100 is 80 degrees. There's the acute angle for number 13.